Welcome! Today we're going to learn about integration using partial fractions. So let's just say you have an integral as you see in item 1. Well, there are several ways you can try to integrate this. You may want to use trigonometric substitution. You can certainly do this, but obviously, well, I shouldn't say obviously, but it will take you quite a few steps to do that. A simpler approach would be to use what we're going to learn about today. It's called partial fractions. So if you go into item 2, you'll see the denominator here. If you factor it, it factors very nicely into x plus 3 and x minus 4. And you can take each factor and use that in a fraction, such as you can see in item 2, we have it equal to a over x plus 3 and b over x minus 4. And then you're going to go ahead and determine what a and b are, and then the integral of those will be much simpler than what we started out with. Now, the key here is you only want to use this method if the factorization of your function, in this case, it's in the denominator that we're referring to, if that factorization is a simple one. If you have to use the quadratic formula, or if you're not dealing with linear or quadratic factors, then this is not the method for you. So, in our case, we have linear factors. And I'm going to talk to you a little bit about what to do when you have linear or when you have quadratic in general, but our example today will be with linear factors. So again, if you have linear factors, there's a couple of scenarios. In item 1, this is like the problem we just did. Our factors are linear. Remember the equation of a line, y equals mx plus b? Well, these factors are in that form, mx plus b, and therefore, the x is to the first power. This makes it the equation of a line, so to speak, if it's y equals mx plus b, therefore it's a linear factor. Now, in our first example, our factors are raised to the first power. So then you create partial fractions like you see on the right side of the equal sign. And we already talked about that earlier. Now in item 2, we have two factors here as well. We have x and we have x plus 2. But x is a linear factor which is raised to the first power. So you can see that becomes a over x, just like we did in item 1. But x plus 2, that's also a linear factor, but it's to the second power. If you have a factor raised to the second power and it's linear, you will, if you look to the right of your equal sign, what I have circled in blue here, you write it as such. B over x plus 2 plus c over x plus 2 squared, because you have to accommodate for the fact that this is a factor squared. Now, in item 3, that's more of the generic formula here as to what to do, because of course if it was raised to the third power, you would have had a third term, and it would be x plus 2 cubed in your third term. So that's the idea. What if you have quadratic factors? Well, in item 1, the first factor is x minus 3. Well, that is linear. That's not quadratic. And we do just what we said earlier. It's going to become a over x minus 3. The second factor, though, is quadratic. How do I know it's quadratic? Well, it's x to the highest exponent here for x is 2, and that tells you you have a quadratic. So that's a quadratic factor. And x squared plus 1 now, if you notice, what do we do with the numerator? It changes. Instead of it being b, it's going to be bx plus c in the numerator. That form is used only when you have quadratic factors. The denominator in our case is just going to be our factor because it's raised to the first power. Now, in item 2, here we have a quadratic as well, but it's raised to the second power. So we have two issues. We got a quadratic, and that means that your numerator's got to be in the form ax plus b, or mx plus b, whatever you want to call it. And the denominator is the factor in the first fraction, but in the second partial fraction, you want to use that factor raised to the second power, because that's what we have. If this was raised to the third, then you would have a third partial fraction, and that would be ex plus f over x squared plus 1 cubed. again, to get that idea or the form, general form, look at item 3. That tells you the general form when you're dealing with quadratic factors. All right, now I gave you a lot of information on what to do in each scenario, but today we're only focusing on linear factors raised to the first power. So our example is, as we showed earlier, in item 1, and we are going to create two partial fractions, a over x plus 3 and b over x minus 4. Now if you go to item 3, you'll see what we can do with that is we can create kind of a common denominator. Well, the common denominator is x plus 3 times x minus 4. So if we do that, we multiply x minus 4 over x minus 4 times the first fraction and x plus 3 over x plus 3 over the second fraction. So we haven't changed the actual fractions, but we have now a common denominator. Now we want to, the denominators are all the same, so there's really nothing to do there, but the numerators are not, and so we need to create an equation with our numerators. So if you look at item 4, we have 1 equals, and then to the right of the equal sign we have the rest of our numerators for our partial fractions. So how do we solve? The key here is we want to solve for a and we want to solve for b. So an easy way to do this, and there's many methods, but this is, in this particular case, is the best method. You want to choose x equals 4. Now why did I choose x equals 4? Well, because that is going to eliminate the term that has the a in it. And this it makes it easier to then solve for b. So if we set x equals 4 and we do a little bit of algebra, in item 6 we solve for b and we get 1/7. Now, we want to now eliminate b and solve for a, so what do? We set x equal to -3. And if we do that, the b term goes away. We can do a little algebraic manipulation and solve for a, and we get -1/7. So now we know what a and b are, which is good news because now we can actually get into the actual integration. So let's move to item 2. We have our integral, and we're rewriting it as two separate integrals. Why? Because we have two separate fractions, so we can certainly do that. In item 3, we bring our constants in the front. So the -1/7 goes in front of our integral sign and the +1/7 goes in front. With constants, you can always do this when you're integrating. It's a wonderful thing. And then the next thing we're going to do in item 4 is we're going to actually integrate. When you integrate 1 over x plus 3, you get the natural log of absolute value of x plus 3. And a similar thing happens when you integrate 1 over x minus 4. Now, if you're not familiar with that type of integration, we used u substitution and our natural log rules to do that. I do have a video that gets into more detail on that particular integration. But at this stage of the game, this is a kind of integral, honestly, you should really have that memorized because you will use this a lot, especially in Calc 2. And that is our answer. And that's how to do integration using partial fractions. Now go practice, and practice some more.